AI agents are reshaping the world now, and it's one of the coolest fields that you can work in. So if you want to learn how to build your own agentic system, watch until the end. On today's video, we are going to build two powerful agents to manage your Notion pages. All you need is just tell them what to do, and they will handle everything. Quick, easy, and hands-free. And as you can see, every word you say is going to turn into action inside your Notion page. And don't worry, I'll provide the link of the GitHub repository of this project in the description below, so don't forget to check it. At the beginning, what is the idea behind agentic AI system? First, we have the user instruction or the user message, and then we pass the user message to the orchestrator. And simply, the orchestrator is the trigger. We can call the orchestrator as the trigger because orchestrator control or decide which agent to trigger based on the user intents. So we have like analyzing the user message to know which agent to trigger based on the user message or the user instruction. So in our case, we have two agents. The first one is the agent that create to-do list based on your instruction. And the second one is calendar agent that set events based on your instruction. And as you can see, you can scale and add more agents to this system or to this architecture. So as I mentioned, after getting the message from the user, we pass the message to the orchestrator to decide which agent to trigger. And then after triggering the agent based on the intent analysis, we check the agent memory to check any common patterns because agent memory is one of the important things that you have to consider because AI agent without memory is like using ChatGPT for first time. So we have memory to make the agent observe our patterns as a users. So after triggering the agent check agent memory to check any previous interaction with the AI agent, and then it sends feedback to the user before taking the action to make the user able to control the process flow. So as we can see, after triggering the agent before taking action, it sends feedback to the user. And now it's time to map the user instruction into tasks. So in case of the user instruction want to access the to-do list agent, we have to map the user message into to-do item to then write it into your Notion page. So after mapping user input to tasks, we then store in Notion. And this is the final step. So yeah, the architecture looks simple, but it covers the idea behind agentic system in which we have agents and we have orchestrator, and for every agent we have memory, and then we use the memory to observe patterns and make the agent evolve by the time. So now it is the time to look at the implementation. And don't worry, I'll provide the link of the GitHub repository in the description below, so don't forget to check it. So before talking about the implementation, I want to show you how you can build or how you can create your own page and link the page to Python. To link your page to Python, we need to do 4 steps. The first one is to visit this URL to be able to integrate Notion page with your Python script. So first thing, visit this URL and it will automatically go to your account, your Notion account. And then you have to create new integration by pressing on this button. And you have to make it internal. And then you just, was there wrong? Okay, I have limited, you have 2 limited integrations. So let's delete this integration. I will delete my integration to show you the process. Okay. Okay. So after visiting this URL, it will open automatically your Notion account. What you have to do is to click on new integration like this, and then add your workspace. I will select the default space for my Notion account, and then I will keep it internal and then press save. I need name, so I'll name this tutorial. Okay, and then save, configure integration settings. You have to copy this API to be able to control the page that we are going to create. So show and copy the API key. So step number 2 is to create new Notion page, the page that you want to automate and link the agents. So all you need is to go to your Notion account like this, and then I will log in with my account. After logging in my account, you can create a new page, and I will call it demo, like this. So new demo page, and we are going to connect our integration to this page. So all you need is to click on this 3 dashes and then scroll down and then select the integration that we created. So manage connections, and as you can see, we have tutorial connection. We just need to click on this connection that we have created and then confirm. So now the page is connected to our connection, or connected to our integration that we have defined using the URL that I will provide in the README file. So after copying your Notion API key, you have to place it there. And then we have the Notion endpoint, which is, as I will show you now, it is this URL. And this URL is consistent, so you don't have to create it for your own page. And the third one is the page ID. And you can access the page ID simply by copying this address right there. So it is directly beside the name of it. So in this case, the page name is demo, and the address of the page is like you can see in my. So just to copy this and place it in the .env file. So the first thing is the API key from the LLMs that you will use for the agentic system, and the second API key is for your Notion connection, and the third one is for the endpoint, which is this URL, and the last one is the Notion page ID that you can copy from the page URL. So this is all you need to start using this for your own Notion page. So now let's jump into the implementation of this agentic AI system. Now, as I mentioned, we have 2 agents. The first one is calendar agent, and the second one is to do agent. And simply each agent has its functionalities. So after triggering the agent, we have number of functions that the agent can take based on your instruction. So let's pass through the code. First, we have class calendar agent, and this is just the constructor that assign the Notion client and Gemini client, memory manager, all these things we are going to pass. So we have process request function, which takes the user input and then send the input to the Gemini LLM that we are using to decide or suggest which action to take based on the user instruction. So after passing the message of the user to the orchestrator, and then we decided that we need to trigger calendar agent, then we need to map the user instruction into event to store in the Notion page. So if we have like long message, we need to narrow down or to make this message represented as event in 3 or 4 words. So we can do this with Gemini or any LLM. This is the purpose of LLM. And the LLM can suggest action from these actions. We have create to create new event, or read just to retrieve data from my Notion page, or we can delete the event. And we have also update option based on the user instructions. You may need to just update the event or update the date or the deadline of this event. So you can do all of these things only using your instruction. So these are the actions and we have method to create event from text. So after suggesting which action to take, as we covered in the first method, then we have to create event from the text or from the user instruction. So now the calendar agent should map the user instruction into action. And if the agent can't extract action from the user instruction, it will simply print this error message to ask the user to provide more details. So the message is going to be like this: I couldn't extract enough information to create an event. Please provide at least an event name and the date. This is the minimum requirements to take the action for calendar agent. So I guess you got the idea. We have text and we are trying to fill specific fields like the event name, the event date, event details, based on the user instruction. And once we don't have enough details, we will ask the user to please enter more details about the event that you want to add in your Notion page. So literally the whole script, I don't want to dive deep into these details. The whole script is about handling all these things. So we have method like update event from text, As I mentioned, this is one of the actions that the agent can take based on the user instruction. So we have update event from text. If the user want to, or the intent. So if the user want to update the event, not create one, based on the suggestion from Gemini, we will call this method to update the event based on the user instruction. So basically we have the text and the function parameters, and it reads the current events in our page or the events that we have in the Notion page, and simply it extracts the content of these events in order to be able to compare the user instruction and the rest of the events. And we have delete event from text as well to delete the event based on the user instruction. So calendar agent has 4 actions to take based on my logic. So you can increase the number of functions to make the agent more capable to do more actions. It's up to you. I'll provide the link of this code in the description below, so feel free to do anything. So we have as well to do agent. It follows the same architecture or the same idea. I hope you got the idea behind making agents and connecting agent to orchestrator, and I will show you how orchestrator is working exactly. But I guess you got the idea behind agents. So now we have agent, which is autonomous software, and this agent as a script or as a code file like to do agent.py. It has number of functions or number of actions that the agent can take based on logic or based on analysis. Something like analyzing the user message intent. If I'm saying to the agent, tomorrow I have to do 1, 2, 3, the agent has to map this into like to-do list with my goals. So it's a kind of intent analysis. So based on the user instruction, the agent or the orchestrator decide which action to take. So I will not pass through to do agent because it's nearly the same logic. The difference only is in the functions or in the actions that the agent can take, but it's nearly the same logic or the same architecture. So now it's time to talk about the most important part in any agentic system, which is the orchestrator or the trigger. So as I showed you, orchestrator is a trigger that triggers the agent based on the user message or the user instruction. So in orchestrator.py we have class called the orchestrator. So just this is the constructor that initializes the memory and the Gemini client and all the things that are going to need to start our agentic system. And this method right there, which is determine agent type, is one of the most important component in our agentic system now, because it is decide which agent to trigger based on such. So we have some sort of keywords. For example, for calendar keywords, we have calendar, event, etc. And we have the same as well for to-do agent. It has to-do, task, reminder, checklist, and so on. So we convert the user message into lowercase and then iterate over the keywords to check the existence of anyone from these keywords. So if we found one, it will return calendar, which means that we need to trigger calendar agent. And we have the same with to do agent. But you may say like, yeah, it's a trivial way to trigger or to initialize the agent. It is the first step, but if this step failed to decide which agent to trigger, we will move to the next step, which is about using the LLM to decide or to define the user intents or the user message intents based on the given text. So if I'm saying something like, I have some tasks tomorrow, or forget about tasks, let's say something harder. So if I'm saying, I have duties tomorrow, and my duties is 1, 2, 3. And I didn't mention duties in this list. I don't know if I mentioned or not. Where is to do? I guess I didn't mention it. And this is good. So if I said something like, I have duties tomorrow, the agent will understand my intent thanks to the LLM. Not my list, but the list as initial step is much faster at the beginning. But if it failed to recognize your message or recognize your intent, then we will move to the next step. So we will not use LLM for everything. If we can solve the problem with checking or iterating over some keywords, that's fine. But if you can't, then you have to have alternative. And in my case, LLM is the strong alternative. But calling the LLM every time I need to check is going to be expensive because you are going to waste more tokens and it will take more execution time. So we have to have like different level of checks from the easier to the harder. I hope you got the idea. So we pass the message to the LLM with this prompt, as you can see, analyze the following user input and determine if it's related to calendar event, scheduling, and then it's related to this return calendar. And as you can see, the second case is to do items, and then the LM will return to do if my message or the user message is related to do list or to do task. And the third one is unknown. The LM or your message isn't clear enough to decide which agent to trigger. So we have process requests. Then we need process request method or function that takes the user input and then send the user message to proper agent. And it also handles the memory section, which I will talk about in a second. So yes, the purpose of orchestrator is to trigger the right agent based on the user instruction. So let's discuss or let's talk about the memory management. So let's jump into memory folder and then memory manager. So I want to show you some sample from my previous interaction with this agentic system. Now, this is the JSON file or the memory of the agent. And in any real live application, you will use cloud-based approach using something like Mem0 to track all these records online, because I'm just trying to teach you the concept. But when it comes to real life scenarios, all these records will be stored in the cloud, but it will be stored with the same format and the same structure. So we have ID of the user prompt, and I'll show you how to create this unique ID. And we have the timestamp, the time of the user message, and the user input or the user message or the user instruction, whatever you call it. And we have like the agent response. So what is the action and what is the type of the action? And it's very important to, kind of evolving your agent by the time. So I'll show you how this kind of memory will help the agent to evolve over the time. So first, I want to show you how to create or how I created the memory mechanism or the memory manager. First, as usual, we have a class called the memory manager. This class has a constructor that initializes the things at the beginning, like creating the JSON files that we are going to use to store the agent interactions. And then we have method to load the memory, as you can see, and save memories, add interactions. And as you can see, these are the fields that we are caring about: ID, timestamp, user input, agent response, and metadata, as I showed you in the JSON file. And this method now, which is update patterns, is one of the most important methods that allow the agent to evolve over time. So as I mentioned, every user has its own tune or its own behavior with the agent. So the agent will check its memory before answering your question. And every user is supposed to have its own agent memory. So it's kind of capturing the user pattern or capturing the user tune or the user behavior. So we have a method called update patterns. And it means the pattern of, and it is based on the user interactions, basically. This method simply is used to track your keywords with the help of another method, which is extract keywords that I'll show you in a second. But this method is used to track common keywords based on your past interactions. And what if you don't have any interactions yet? So it will go and store your first message as interaction. So by the time your memory or the memory of your agent is increasing, and it means that the agent is tracking more about your tune or your pattern or your keywords. So in this case, or the first case is about checking the keywords, and the second one is about storing your interaction. You don't have any previous interactions or you don't have enough interactions with the AI agent. And now the idea of memorizing or agent memory is to find overlapping between the new message, user, and the previous interactions. So it's kind of comparing the overlap between your message and the previous messages. And the agent has your message or your previous or past messages and the responses or the triggered agent. So it's kind of the agent can memorize your instructions and the corresponding actions based on your instructions. So when you pass new message to the agent will check the memory based on your historical interaction with the agent, and then it will check the overlapping between all the actions or all the user instructions and the corresponding agent triggering, function calling, and all the stored parameters or stored fields. So as we can see, it calculates the overlapping score based on the keywords extracted from the memory and from your instruction. And after calculating the overlap, it will return the best matching message. And why we need to know the best matching message? Simply to decide what is the best agent or what is the closest agent to call based on your intents. So it's kind of supporting the orchestrator or supporting the way of triggering agent, and after triggering agent, which method to call from the agent itself. So we have two stages, three stages, having user message and then pass the user message to the orchestrator and then analyze your intents and then move to the triggered agent. And then this agent has methods. We need to decide which method to call based on your. I have mentioned the part of creating the unique identifier or the ID. And we use MD5 to create like identifier for all your interactions. So the agent can access it using the address or whatever you call it, the address ID, identifier. All these terms are the same, I believe. Anyways, so what is remaining? The project is quite large. So yeah, we have Gemini client that manage the connections between you and Gemini and sends all your requests from the orchestrator to Gemini client. And the main task of Gemini is to map the raw message or the raw text into specific fields to fill in your Notion page. Like you can see, for calendar events, we have event name, all these fields, event name, start date, and the date description, location. And we have for to-do list, we have specific fields like task name, due date, priority, status, and notes. It's a quite long, I don't know. I don't want to get into all these details because, you can use AI to add features or to clarify something to you that you don't understand. So this project really is scalable. And as I showed you before, you can just add more agents. Once you have strong trigger or a strong orchestrator, you can have 1,000 agents and the orchestrator is coming to handle all these agents without even loading all these agents in your memory. So now the orchestrator has the decision to take about which agent to trigger. So if you have 1,000 agents, the same logic can be applied. Having orchestrator of agents, trigger based on intent analysis, and then reflect this in the agent memory. I think this architecture, it looks simple, but you can scale it to. So to run our agent, you have to run main.py and then enter your message. And my message is like this: new event after 2 days about AI in tech world. Anything. So yeah, created event AI in tech world. And as you can see, the date is relevant to the actual date. So now it's 7. It's a 7 and 7 plus 3 equal 9. So the agent can map your text into dates. You can write something like, after 2 days, I have some tasks as the following, and going sorry, going to the gym, and let's say the university and Yoni, and enter. Here we go. So created to do gym and Yoni, and this is the date. So let's check. As we can see, AI in tech world with the date, and we can go back and check to do items. We have our new task, gem and Yoni with the date, but I didn't mention the priority. I didn't mention any status, so the agent will automatically understand. Thank you for watching. I hope you enjoyed this, and see you in the next video. Take care.